So we're going to start with the second portion of 6.1, absolute extrema. We're starting with example 6 from the handout. So again, remember we have to have a closed interval, which they've given us, which is here. We're going to take the first derivative to find my critical numbers. So remember, when you're taking the derivative of a base e, you take the derivative of the exponent and you keep what you have. So that's how I got a negative 3e to the negative 3x. So that's my first step. Second step, find my critical numbers, which says set it equal to 0. So I'm going to solve this piece over. So it's going to give me 3e to the negative 3x equals 1. I'm going to rewrite this. So I'm going to divide by 3. e to the negative 3x equals 1/3. Remember, I can take the natural log now of both sides. So that's going to, these are inverses, so they cancel out. So I get a negative 3x equals the natural log of 1/3. Okay. And so remember, my goal here is to solve for x. So now I divide by a negative 3. Be careful when you're typing this into your calculator. Make sure that you close your parentheses. You will get 0.366. Okay. I also want you to realize some of you may actually solve this a slightly different way, and do realize, as a side note, natural log of 1/3 is the same thing as natural log of 1 minus natural log of 3, because it's division, and natural log of 1 is 0, so it's actually the same thing as natural log of 3. So you could have solved it in a slightly different way, and you would have gotten x is equal to, the negatives would cancel because you have a negative natural log of 3 over negative 3, so we get a natural log of 3/3. The 3's don't cancel, okay? So this would have given you the same answer as this. Either one would be acceptable to me. So remember, now at this point, go back to the original function, start with the endpoint, which is negative 1. Natural log of 1/3 over negative 3. Please don't use the rounded answer. Now, if you had typed it in your calculator, you can use the answer button because that will keep all of the decimal places. But please be careful. So if you already have this portion in your calculator, what I would suggest is to type this in. You would enter this, I'm going to kind of put it in a box. You would use the A and S button minus E caret A negative 3 times the A and S button. That would give you the correct non-rounded piece for that middle one. So other two pieces, we would have a negative 1 plus e to the positive 3rd, which would be my exact answer. If you put that in your calculator, you're going to get 19.09. If we plug in the middle piece into my calculator, I'm going to get 0.6695. And for the f of 3, we're going to get 3 plus e to the negative 9, which gives me 3.001. So looking at these answers, my smallest value is here, and my largest value is here. So my answer for this problem would be, I have an absolute minimum of 0.6695 at x equals natural log of 1/3 over negative 3, and we have an absolute max of 19.09 at x equals negative 1. Again, you can check yourself in your calculator. Remember, it's going to give you approximations usually with those pieces. And always, if you're not sure, ask me what you want me to round. You need to round to as well. So going to our word problem here, total profit. Notice it's in thousands of dollars for the sale of X 100,000 automobile tires. So we do need to be careful with our units when we finish the problem. Other piece that I need you to be clear on is that this is not a closed interval. So we actually have to go back to what we did before for extrema to prove that it's an extrema. Okay? because we're not looking at a closed, which means we aren't guaranteed a closed piece. So we're going to actually have to do this to see that idea. So I'm going to start off again, find my derivative of my profit function, negative 3x squared plus 18x plus 120. Find my critical numbers. So I'm going to go ahead and factor out the negative 3. So it's going to give me an x squared minus 6x minus 40. That factors to x minus 10, x plus 4. So that gives me x equals 10 or negative 4. Negative 4 is not in my domain. It doesn't make sense for the number of tires to be negative as well. So right now I have p of 5, which is my first endpoint, and if I plug that into the original function of negative x cubed plus 9x squared plus 120x minus 400, I'll get a positive 300. If I plug in my 10, which I have, I get 700. But notice again, there wasn't a top bound, so we really do need to prove that it goes down for the rest of the interval. So this goes back to that first derivative test. Okay. We would have started again at 5, meaning I'm not including anything over here. If I plug in 6 into my original function, I'm going to get, and sorry, not my original function, I would be plugging it to my first derivative for this first derivative test. So p prime of 6 would be 120, which is a positive. If I plug in 11, I'm going to get a negative 45, which is there. So it means I'm increasing and decreasing. So that proves I have a maximum at that value. So again, remember that you have to be careful. If it's not a closed interval, you actually still do have to prove it. So we have a maximum profit. Make sure you're careful of your units. $700,000 when, remember, this was in hundreds of thousands. So I think I have one too many zeros. So it should be 1 million tires sold. So I multiply 10 times 100,000 and that adds that one extra zero on it. That's my answer. Because there is no top bound, you actually do need to either explain that as I get an x bigger and bigger and bigger, that eventually this is going to get smaller and smaller and smaller, my original function. Okay? But the best way to prove it is to go back to what we did when we were finding max and mins. Going to the last problem here for number 8, we do have a word problem again. We have a minimum value we're looking for. Okay. Notice keyword there is average cost. So remember what we have to do to get the average cost, and we have two different intervals. So average cost, remember, means divide by x. And a lot of you on your tests in the past forgot to go ahead and simplify it, which makes it easier to actually take the derivative of, because this is actually x squared plus 37 plus 250x to the negative 1. This is what I'm going to take the derivative of. So my derivative of my average cost is going to be, looking again over here at the part I have, I'm going to highlight it just so you can see where I'm going from here. 2x, 37 goes away, minus 250x to the negative 2. I'm going to rewrite this so I can get a common denominator. So I need to multiply this by x squared over x squared. That gives me 2x cubed minus 250 over x squared. Find my critical numbers next, which means take our numerator, 2x cubed minus 250, set it equal to 0, and set your denominator equal to 0 as well. Add 250 to both sides, divide by 2. Take the cube root of both sides, which gives you x equals 5. X equals 0 is not in my interval for either one of these, so I can go ahead and cross it out. The x equals 5 will be in the first interval. So first interval, we're going to take, again, be careful. We're going to the average cost function, which is what I have highlighted here in yellow. Okay. We're going to evaluate that at 1. And we're going to evaluate it at 5. And we're going to evaluate it at 10. Use your calculator, and like I said, we actually are using that piece up there, c equals x squared plus 37 plus 250 over x. That's what I'm plugging in for. We get 288 when we plug in 1. We get 112 when we plug in 5, and we get 162 when we plug in 10. So remember, I'm not looking for max and min in this case. This problem actually asks for a minimum. So we're looking across here. This would be my minimum. So we have an absolute minimum of 112 at x equals 5. Now this is where you'd look back at your wording for the problem. If it gives you any units, you would need to make sure you're adding that to it. For B, notice I've already calculated the first endpoint. Which is 162. My critical number was 5. That doesn't fall into this piece here. So I have that here, and so I'm not going to have any critical number to evaluate because it's C10 to 220. So now I need to evaluate again back into this function here. Plug in 20. You plug in 20, you will get 449.2. So now my absolute minimum of 162 at x equals 10.